Welcome. So in this video, we talked last video about the arrangement in the autonomic nervous system synaptic junction, and we talked about how drugs can affect the process of neurotransmission, either directly or indirectly. Um, Next here, I just want to also talk about that in reality, it's not one division of the autonomic nervous system that controls um, one organ or set of tissues alone. You have multiple influences. It's like a yin yang. So for example, in the heart, now even though the heart is not specific here, here what the figure is referring to is the SA nodal cells, the sinoatrial node cells that increase the heart rate or decrease the heart rate. So this is telling you that yes, we do have parasympathetic innervation. That is, those post-synaptic receptor cells, in this case on the SA nodal cells, they have receptors for acetylcholine, parasympathetic acetylcholine, to cause the decrease of heart rate. The same cells, the SA nodal cells also have adrenergic receptors that in the event that you have adrenaline or epinephrine being released, epinephrine will go and bind those adrenergic receptor subtypes on the same SA nodal cells, and it will cause the exact opposite. It will increase the heart rate. So it's important to note that many tissues have multiple innervations. So when you read, for example, table 15.3 and 15.4, you see how there's a lot of overlap. Usually in most organs, they have opposing effects. Now, so we have each organ system has what we call an autonomic tone. That's the division of the autonomic nervous system, cholinergic or adrenergic, that controls its function most of the time. And that tone, so it's mostly the parasympathetic, the cholinergic, that controls the tone for all our involuntary, that is autonomic functions. And so it's the one that controls everything except the vascular system, your blood vessels, that is driven primarily by sympathetic innervation. So what this is showing is the arrangement in the parasympathetic nervous system. Previously, I'd only been showing one neuron, and there's more than one neuron. There's actually two neurons in that arrangement, in that anatomical arrangement. So previously, this is what we looked at, this post-ganglionic neuron. That's the one that releases acetylcholine on the SA node, as we described. It could be various organs, but my previous example is the SA node. So this is what we described. But what this is showing is that that same neuron is controlled by another neuron, the preganglionic neuron, that comes from the central nervous system. And the point where they meet, where the preganglionic neuron controls the postganglionic neuron, is called a ganglion. And the neurotransmitter that is released at every ganglion is acetylcholine. And so when acetylcholine is released, because of some central nervous system effect, acetylcholine will bind its receptor, the receptor on the cell body of the postganglionic neuron, and that will act. If there's enough to reach the threshold, that will cause an action potential to be fired in that postganglionic neuron, and ultimately that gets to the synapse, where it releases acetylcholine again, and that's what controls the SA node. Okay, so in the autonomic nervous system, this arrangement, this two neuron arrangement, is conserved. Okay. So this here is what we just showed. Now, I have blocked out the sympathetic for now because the sympathetic, for the most part, uses norepinephrine in the postganglionic neuron, but I've included the somatic. Now, somatic system is your voluntary, that is not autonomic, voluntary nervous system. And so your somatic system, notice it's only one neuron, one motor neuron, compared to the parasympathetic, which is two motor neurons, two neurons, and at both ganglia, at both the ganglion and the synapse, acetylcholine is being released. This one only has acetylcholine being released in the skeletal muscle for voluntary control of movement.